Hello and welcome to Prepspot. In this video we are going to know about a groundbreaking development in futuristic transportation that has captured the imagination of the nation and the world alike, India's first Hyperloop test track. Announced in March 2025, this project marks a significant milestone in India's pursuit of advanced, high-speed travel systems and stands as a testament to the country's commitment to innovation under initiatives like Make in India. In this session, I will provide a comprehensive analysis of the Hyperloop test track, examining its background and context, the origins of the technology, the technical details involved, and the broader economic, environmental, and geopolitical implications of this ambitious project. This analysis is particularly valuable for competitive exam aspirants, as it encapsulates a range of interdisciplinary issues including technology, infrastructure, policy making, and international trade. To begin, let's set the stage by understanding what the Hyperloop is. The Hyperloop is a high-speed transportation system conceptualized by Elon Musk in 2013 through a white paper, envisioning a mode of travel where passenger or cargo pods move through low-pressure tubes at speeds of up to 1,000 km per hour. This concept relies on technologies such as magnetic levitation or air bearings to minimize friction, allowing for incredibly fast travel over long distances. Imagine reducing the travel time between major cities like Mumbai and Delhi from the current 16 hours by train to under an hour. India, with its vast population of 1.4 billion and rapidly expanding urban centers, faces enormous challenges in managing traffic congestion, long travel times, and environmental degradation. The Hyperloop test track, which spans 5 kilometers and is currently designed to achieve speeds of up to 500 kilometers per hour in its testing phase, with full-scale models targeting speeds of 1,000 kilometers per hour, represents a bold step towards addressing these challenges and transforming the country's transportation infrastructure. The Hyperloop test track was announced on 10 March 2025, during a press conference in New Delhi at 10 a.m. Indian Standard Time. This announcement was made in conjunction with the vibrant Gujarat Global Summit, further highlighting the government's focus on cutting-edge technology and infrastructure development. The project is being developed in Ahmedabad, Gujarat, a strategic location chosen not only for its industrial significance but also for its proximity to key logistics hubs and favorable land acquisition conditions. With an allocated budget of approximately 500 crore rupees for construction and testing, and an additional 1,000 crore rupees earmarked for future phases, this initiative is poised to drive significant advancements in both technology and economic growth. Historically, the Hyperloop concept represents a radical departure from conventional modes of transport such as trains, airplanes, and automobiles. Traditional transportation systems are often hampered by friction, air resistance, and energy inefficiencies, which result in longer travel times and higher emissions. The Hyperloop system, by contrast, is designed to operate in a near-vacuum environment, significantly reducing air resistance and allowing pods to glide with minimal energy loss. This technological innovation not only promises to drastically cut travel times but also offers considerable environmental benefits, as it is projected to produce substantially lower carbon emissions compared to conventional air and rail transport, a factor that aligns well with India's commitment to achieving net zero emissions by 2070. The origins of the Hyperloop technology can be traced back to earlier research and feasibility studies conducted by prestigious institutions like IIT Mumbai and IIT Madras, which began exploring the potential of this concept as early as 2016. Over the years, these studies laid the groundwork for a series of experimental prototypes and pilot projects, culminating in the formation of Hyperloop India, a hypothetical company established in 2020 to spearhead the development of the technology in the country. This collaborative effort between Hyperloop India and the Ministry of Railways represents the convergence of public policy and private innovation, a model that has been central to India's technological advancements in recent years. One of the most critical technical aspects of the Hyperloop test track is its vacuum-sealed tube. The 5 km track is designed to maintain an air pressure of just 1/1000th of atmospheric pressure, thereby reducing drag to almost negligible levels. This is achieved through advanced vacuum pumps and sealing technologies that ensure a stable, low-pressure environment. Within this tube, the Hyperloop pods, constructed from lightweight materials such as carbon fiber, are designed to carry between 20 to 30 passengers in full-scale operations. The pods are levitated using magnetic levitation, maglev, technology, which not only minimizes friction but also enhances energy efficiency. Propulsion is provided by linear induction motors, which accelerate and decelerate the pods smoothly along the tube. These technical innovations are backed by rigorous testing and simulations, conducted with the help of supercomputers at leading research institutions such as IIT Bombay, ensuring that every aspect of the design meets the highest safety and performance standards. Economically, the potential impact of a fully operational Hyperloop system in India is enormous. Current high-speed rail services, like the Vande Bharat Express, achieve maximum speeds of around 180 km per hour, which pales in comparison to the projected speeds of the Hyperloop. Faster travel times could revolutionize domestic connectivity, making it possible to commute between major cities in a fraction of the current time and significantly reducing the economic costs associated with long-distance travel. For example, if the Hyperloop could reduce travel times between Mumbai and Delhi to under an hour, it would not only enhance productivity by reducing time lost in transit but also stimulate regional economic integration and boost tourism. Furthermore, the project is expected to create thousands of jobs in both the construction and operational phases. Hypothetical reports from Niti Aayog suggest that the project could generate around 10,000 jobs during the construction phase and an additional 5,000 in operational roles by 2026, contributing to broader economic growth and technological innovation. On the policy front, this Hyperloop initiative is emblematic of India's broader push towards modernization and digital transformation under the Digital India and Make in India campaigns. The government's decision to invest heavily in futuristic transportation technologies is driven by the need to not only upgrade the country's infrastructure but also to position India as a leader in global technological innovation. In this context, the Hyperloop test track is seen as a strategic investment that could transform the transportation sector, reduce environmental impact, and enhance India's competitiveness on the global stage. However, the project is not without its challenges. The high cost of construction, the technical complexity of maintaining a near-vacuum environment over long distances, and issues related to land acquisition and regulatory approvals present significant hurdles. There have been protests by local farmers in Gujarat who are concerned about the displacement and environmental impact of the project, highlighting the delicate balance between technological advancement and social impact. Another key aspect to consider is the geopolitical dimension of this initiative. As the global landscape shifts towards more sustainable and technologically advanced modes of transportation, countries around the world are investing heavily in high-speed transit systems. India's foray into Hyperloop technology is not only a domestic policy decision but also a strategic move to enhance its international standing. By successfully developing and deploying such an innovative system, India could potentially export this technology to other developing nations facing similar transportation challenges, thereby strengthening its role as a technological leader in the region. Moreover, this initiative could pave the way for future public-private partnerships, fostering a collaborative environment that leverages both government support and private sector expertise. For competitive exam aspirants, it is crucial to understand several key terms and concepts related to this development. Terms such as Hyperloop, vacuum technology, magnetic levitation, linear induction motor, and friendshoring are integral to the discussion. Additionally, the concepts of supply chain diversification, tariff adjustments, and bilateral trade dynamics are relevant, as they provide context to India's broader economic strategy. The integration of these technological and economic dimensions not only offers insights into the future of transportation but also highlights the complex interplay between technology, policy, and global market trends. Let's also consider some specific figures and data that illustrate the scope of this project. The test track is 5 km long, designed for initial speed trials up to 500 km per hour, with full-scale models expected to reach speeds of 1000 km per hour. The project has an allocated budget of approximately 500 crore rupees for construction and testing, with an additional 1000 crore rupees planned for subsequent phases. These investments are anticipated to have a significant multiplier effect on the economy, potentially creating around 15,000 jobs by 2030. Furthermore, the Hyperloop's potential to drastically reduce travel times could have a transformative impact on economic productivity, with estimates suggesting that faster transportation could boost GDP by up to 1% by 2040. The project's location in Ahmedabad, Gujarat, was strategically chosen for its industrial hub status and proximity to major logistics centers, with the site's coordinates approximately 23.0225 degree N and 72.5714 degree E, making it well suited for large-scale infrastructure development. The implementation of this project will occur in phases. Following the announcement on 10th March 2025, construction is set to begin on 1st April 2025, with a groundbreaking ceremony in Ahmedabad. Initial testing is expected to start in late 2025, with operations running daily from 9 a.m. to 5 p.m., and progress will be reviewed quarterly starting from 1st July 2025. Full-scale implementation is planned for 2030, with commercial operations potentially commencing by 2035. These timelines reflect the ambitious nature of the project and the careful planning required to address the technical and logistical challenges involved. In summary, India's first Hyperloop test track represents a bold and innovative step toward revolutionizing transportation in the country. This initiative is driven by the need to overcome the limitations of traditional transport modes, reduce travel times, and create a more sustainable and efficient transit system. With its roots in Elon Musk's original Hyperloop concept and building on years of research and feasibility studies by institutions like IIT Mumbai and IIT Madras, the project exemplifies India's commitment to embracing futuristic technologies under the Make in India initiative. However, the path forward is not without challenges, as the project must navigate high costs, technical complexities, regulatory hurdles, and potential social impacts such as land acquisition issues and environmental concerns. Economically, the Hyperloop could offer substantial benefits, from job creation and enhanced connectivity to reduced carbon emissions and increased productivity, positioning India as a leader in next-generation transportation. Geopolitically, it underscores India's ambition to assert its technological prowess and to transform its infrastructure in a way that aligns with global trends in sustainable development. For competitive exam aspirants, this topic provides a rich tapestry of issues, from technical innovations and economic strategies to policy making and international trade, that are essential for a comprehensive understanding of modern governance and technology. It illustrates how a single infrastructural project can have far-reaching implications for economic growth, social change, and international relations. Answer this question in comments. The correct answer will be given heart and pinned. Lastly, we just want to let you know that we are a newly emerging online platform for competitive exams. Creating educational explainer videos like these requires a lot of effort, money, and time. If you like these videos and want us to excel and create videos in all categories of competitive exams, then you can consider supporting us with a one-time donation through the Ko-fi platform and also by becoming a member through Patreon. This will help us create more such informative educational videos in the competitive exams space. So, one last time, subscribe and share this channel with all your friends who are preparing for competitive exams. And also, follow us on social media platforms. The links are given in the About section of the channel and also in the video description. So, see you in the next video.